Radiation is all around us. From visiting a doctor's office to get an x-ray, to being on a high-altitude jet, or simply existing on the surface of Earth, we cannot get away from it. However, it is much stronger in space. When we send astronauts into deep space, we will have to take precautions against it to ensure their safety. My name is Ben Pearson. I'm the Roadster Tracker, and today I would like to talk to you about radiation in deep space, particularly for astronauts headed to the surface of Mars. Earth's magnetic field provides a protection for those on the surface or in low orbit. Only 24 of the Apollo astronauts have gone beyond Earth's protective magnetic field. Astronauts on the International Space Station receive about 15 times the radiation that they would on Earth. While this is higher by a factor of 3 than that required for radiation workers, it is still only a small fraction of what would happen in deep space. It is expected that the exposure will be about 4 times higher in deep space than it will be on the International Space Station in low Earth orbit, given similar radiation protection. The radiation dose experienced by astronauts on a trip to Mars will be about 1,000 millisieverts spread over the course of 2.5 years. Most of this will occur from the time transiting between the two planets, about 2/3 of it. The radiation on the surface of Mars will only be about double what an astronaut would receive on board the International Space Station. However, this exposure goes up to a factor of 4 to 5 for the deep space duration. During this same 2.5 years, the amount of radiation that a radiation worker could be exposed according to the safety guidelines of OSHA on Earth is about 125 millisieverts, and on board the space station, it would be about 400 millisieverts, which is only a small fraction of what those astronauts would receive on their journey to and from Mars. NASA has an exemption from OSHA to allow the astronauts to have exposure to higher levels of radiation than any other United States workers. Even given these higher guidelines, the mission to Mars will still exceed them. However, it will be less than the lifetime limits for these astronauts. It's likely that the first astronauts that go to Mars will be in their 40s to minimize the effects of long-term radiation damage. There are 2 primary sources of radiation in deep space. The first is the sun itself. There are 2 forms of radiation in turn for the sun. The first is the radiation that it exhibits at all times in all directions. The second is a much more dangerous form of radiation known as coronal mass ejections, also commonly known as solar storms. In this image of the sun, one can see a solar storm brewing in the right part of the image. If this storm is pointed towards Earth or towards the astronauts, they can be exposed to serious danger. A large storm that occurred between Apollos 16 and 17 could have caused significant damage had it occurred during one of the Apollo missions. Still, if they quickly returned to the surface of the Earth and were presented to hospitals dedicated to protection against radiation damage, they could have been saved easily. This will not be an option for astronauts heading to or from Mars. The second is a pervasive form of background radiation known as the galactic background radiation. This is very difficult to shield against, requiring thick materials. On the surface of Mars, it should be relatively easy to protect against it using dirt from the surface of the planet. However, while in transit, this will not be useful. The effect of this radiation is about 200 times stronger in deep space than it is on the surface of the Earth. To protect against these forms of radiation, one must design the spacecraft accordingly. To protect against the solar radiation, only a shielding of 1 inch or 2 should be sufficient to keep the astronauts quite safe. Specifically, a combination of aluminum and titanium has provided the most effective protection in models, given this 1 inch thickness. However, for its mass, water can also be used. For protection against coronal mass ejections, a specific part of the spacecraft should be designated to keep the crew safe during these solar storms. Additional shielding in the form of water or thicker materials could be provided to keep the astronauts there safe. When a storm is detected, astronauts can take shelter in this special bunker that they will have on board the spacecraft, which will enable them to stay safe for some period of time. These storms are constantly monitored from the surface of the Earth, both using telescopes as well as specific space-based observing platforms to protect satellites, infrastructure, and even the astronauts on board the International Space Station. Given this advance notice, astronauts should be able to easily seek safety in their storm shelter. Radiation, while it is a serious concern, can be dealt with if one is willing to expose the astronauts to somewhat more radiation than they would be otherwise. While this might seem like a significant increase, it is not expected to significantly decrease the lifetime of these astronauts. Let me know whatever questions or comments you guys have about this or anything else space exploration related. Until next time, keep on tracking and take care.